Hello class. Today we're going to talk about graphing expressions. This is the next step in evaluating expressions with t-charts. Today we get to find out why we create a t-chart. Okay? But first, let's review a few things about a graph. Okay, so this is what we call a coordinate plane or a graph. Okay, there are several parts in here that are extremely important. The first thing I want to look at is it's divided into 4 sections, which we call quadrants. This quadrant up here, which is your top right, is what we call quadrant number 1. Okay, the one over to your left going counterclockwise is actually quadrant number 2. The bottom left is going to be quadrant 3, and the bottom right is going to be quadrant 4. Notice we do identify those with Roman numerals, and the way you can remember the quadrants is it makes the letter C. Okay, we go counterclockwise. Okay. There's a few other things that are really important. You'll notice that we've got these 2 dark lines in the middle, which we call axes. The one going across is called the x-axis. The one going up and down, the vertical one, is called the y-axis. So this is the x, and this is the y. And a lot of times when you do the star test or whatever, they will have a letter out beside the axis to tell you which one it is. Okay. Where those 2 axes meet is a very special point. This one right here, it's called the origin. Okay, so this is the origin because this is where everything originates. And it does have a location. Its location is 0, 0. That is its address. Okay, so a few other points. Take, for example, this point right here. This point, in order to do a coordinate, you start at the origin and you go right or left first, then you go up or down. So this one says it goes right 1, 2, 3. So you'd put a 3 in the first spot, and it goes up 1, 2, 3, 4, 5, 6, 7. So it's 7 in the second spot. So in a coordinate, the first number is always the x number, and the second number is always the y number. So if we do this coordinate right here, this one says that we're going to go 1, 2, 3, 4, 5, but we're going left. So that means it's going to be a negative value. And then if it goes down, it's also going to be negative, but this one goes up, so it's 1, 2, 3, 4, 5. So we have the coordinate negative 5, 5. So the coordinates in the top right are always going to be positive numbers. The coordinates in quadrant 2 are always going to be negative, positive. In quadrant 3, they're always going to be negative, negative. And in quadrant 4, they're always going to be positive, negative. So that's what your numbers are going to look like if you have to graph things in those quadrants. Okay, so let's slide on down and let's find out why we actually need to organize our data in a t-chart. Okay, so we've been working on evaluating expressions in this t-chart right here, and we know that this t-chart here says if x is negative 2, then x plus 4 is what? And what I've had you do is I've had you show your work out here to the side. So we would take our negative 2, we would plug this in. Negative 2 plus 4 gives us positive 2. Okay, then the next one. Okay, we plug negative 1 in now. So negative 1 plus 4 gives us positive 3. We plug 0 in. 0 plus 4 gives us 4. So in the last video, we talked about looking for the pattern going down this side. So if our pattern on the left is 1 and our pattern on the right is 1, okay, then all we're doing is counting. Those are the 2 patterns that we're looking for in algebra. Okay, so our pattern here, I'm going 2, 3, 4, so the next one should be 5 and 6. We'll get back to a little bit later on about this pattern right here, or these 2 numbers. Okay, so why do we actually need to organize our data this way? Because what happens is we create a set of coordinates whenever we create this t-chart. Okay, so for this one right here, we're going to create a graph. So I'm going to draw 2 axes. I'm going to label my graph with some tick marks here. So 1, 2, 3, 4. I'm going to do 4 that side. 1, 2, 3, 4 this side. It's about all we need because this is our x value, and we've got numbers from negative 2 to positive 2. Now for the y value, or for the y-axis, I'm going to have to go all the way up to 6 at least. So 1, 2, 3, 4, 5, 6. Go up one more, and then a couple going down. Try to make them all about even whenever you do that. Now what this basically says is this first set of numbers is a coordinate that we can put on a graph. So like we talked in previously when we were dealing with that graph up there, okay, this -2 is going to be from the origin. It says we're going to go left 2. And then this +2 says I'm going to go up 2. And then I'm going to put a dot. All right? And then we'll do the next one, -1, 3. So -1, up 3. Okay? And then 0, 4. So I move right or left none, and I go up 4. And I put a dot. Now what are you noticing about those dots? Looks like they're kind of forming a line. Okay, this next one's going to be 1, 5. So I'm going to go right 1, up 5. And I'm going to go right 2, up 6. Now you'll notice that every one of those kind of fell in a line. And that's because every one of these expressions, we call them linear expressions. Okay, now, the one thing I want you to kind of think about is, okay, we only used x values of -2 through +2. Could there be other x values? Could there be a -3? Could there be a -4? Or a +3 or +4? Or could there be a 0.5 or a 0.1? Could there be points in between 0 and 1? And yes, there are. And the way we represent that on the graph is we play connect the dots. And we connect our dots, we extend out past on both ends, because that shows that all of the points in between those dots are also part of the line, and the line keeps going in both directions. So this expression, what it does is it actually makes a unique picture. And all the ones that we deal with in 7th and 8th grade, or in 7th grade in particular, is linear functions. And that's what this is right here. It makes a linear function. Okay, so let's see if we can do another one real quick. So here's another one. This was another one that was off the homework that you had to do. We just had 2x. So we plugged in our values and we did 2 times -2 gives us -4. 2 times -1 gives us -2. 2 times 0 gives us 0. So we're actually counting by 2's. So this one then would be 2, and then this would be 4. And now we're going to put this on the graph. So this first coordinate, okay, this stands for your x value, and this stands for your, believe it or not, your y value. So this is why most of the ones that we deal with, they're actually going to say y equals 2x. Okay, and we'll talk more about that tomorrow as well. So we've got this coordinate, -2, -4. So I'm going to come over here, and we'll start at the origin. I'm going to go left 2, down 4, and put a dot. Okay, then I'm going to go left 1, down 2, put a dot. And then right or left none, up or down none. So this one is actually on the origin. Then I'm going to go right 1, up 2, right 2, up 4. Okay, and then to finish this off, what we're going to do is connect the dots and extend out in both directions. And that is the graph or the picture of what 2x looks like. Now, do you notice any difference in this one and the one we just did previously? Well, this one is a little bit flatter than this one. You're going to find out that the bigger this number is, this coefficient, the steeper your graph is going to be. Okay, what about this one? Okay, let's have you try this one on your own. Pause the video and work this one. Okay, let's find out how you did. So the first thing I'm going to do in this particular problem is I'm going to change this minus to a plus next to its opposite so that it's easier for me to work. And then I'm going to start with plugging in my values. So we've got 3 times -2 plus -3. Well, 3 times -2 gives me -6 plus -3 gives me -9. Okay? Then 3 times -1 plus -3. Well, 3 times -1 gives me -3 plus -3 gives me -6. And then 3 times 0 plus -3. Well, 3 times 0 is 0 plus -3 is -3. So what's my pattern? Okay, if you'll notice, we are adding 3 each time because on that number line I'm going to the right. So if I add 3 to -3, I get 0. Add 3 more, I get 3. Okay, and now we put our points on our graph. So -2, -9, -1, -6, 0, -3, 1, 0, 2, 3. And then we play connect the dots. And that's what it should have looked like. And again, as I said, as that number increases, the graph gets steeper. Let's try one more. One more. Now, what's different in this one? You'll notice the coefficient is negative. You think that'll have an impact on your graph? Well, let's see. So we plug in. -2 times -2 gives you 4. -2 times -1 gives you 2. -2 times 0 gives you 0. Well, this one, it looks like we're subtracting 2. So if I subtract 2 more, I get -2 and -4. So now I come to graph it. -2, +4. -1, +2. 0, 0. +1, -2. +2, -4. And then we play connect the dots. Now, this one was a -2x, where the one that we did earlier was a +2x. Do you notice the difference in the graphs? With +2x, the graph is what we call increasing. From left to right, it's going uphill. This one, from left to right, it's going downhill. So that negative actually flips my graph. So you need to pay attention to that. If my value, if my coefficient is positive, it's going to be going uphill. It's going to be a graph that's increasing. If my value, my coefficient is negative, it's going to be going downhill. And that's how we graph algebraic expressions.